Hello everyone. Welcome to the first build progress video of Team Embarrassing Engineering's Beetleweight combat robot, Tekkadan. In this video, we will share with you the most recent news on the building progress and explain each component and system that has been completed. If you are interested in the design of Tekkadan, please watch our previous video where we have covered the design and the CAD models of the robot. As the title suggests, today we will be looking at all the 3D printed components of Tekkadan. Many of the commercial off-the-shelf and custom metal components have not yet been delivered, but since we do have in-house 3D printing capability, the plastic printed components were completed first. Anyways, let's examine the parts that were made. The first and largest part that was 3D printed is the unibody chassis. It was printed using Polymax filament on our Ditto Pro printer at a layer height of 200 micrometers, temperature of 230 degrees Celsius, 4 wall layers, and 80% infill. As for the design of this part, I really like unibody chassis designs because they offer a lot of rigidity, as well as a lot of redundancy and toughness, as the entire structure is load-bearing. If the chassis is multiple components held together with screws, for example, a large hit could separate a section or split a bulkhead right off. With a unibody design, a big hit could create a big opening or cut, but the surrounding material would support it, making it stay in one piece. The other thing I like about unibody is that there is no assembly required, so it saves a lot of time putting the robot together. The front part of this chassis is painted yellow with acrylic paint for aesthetics purposes to fit the color scheme that we planned. Now onto the top panels. They were printed also using Polymax filament on our Ditto Pro printer at a layer height of 200 micrometers, temperature of 230 degrees Celsius, 4 wall layers, but at 100% infill. They are printed at 100 because they act as the relatively thin top armor. The front panel also acts as the mounting points for the weapon motor. The top panels will all be mounted onto the chassis via screws through these holes. The panels are also painted to fit the color scheme, the blue and yellow being hand-painted acrylic, using some tape for masking, and the red was a base layer that was spray painted on. The next set of components that were 3D printed are the wheel guards. They were printed also with Polymax, with the specs the same as the chassis. The wheel guards also mount to the chassis via screws. They are supposed to be originally painted black using spray paint. However, during the painting process, one of the wheel guards fell into undried red paint and produced an interesting pattern, so I decided to keep it as I thought it looked quite cool. The last part that is 3D printed is the motor side pulley for driving the weapon. They were printed also with Polymax with the Ditto Pro 3D printer, with the same setup as the chassis and the wheel guards. The pulley side of this will spin a 4mm O-ring belt that delivers power from the brushless motor to the weapon. To attach to the motor, there's a central hole to fit directly into the rotating outrunner rotor of the motor. For torque transfer, there are 4 protrusions on the side of the pulley that fits into the openings of the rotor, acting as a dog clutch that locks the rotation of the pulley with the motor. Being on the bottom of the robot, which is all white, this component does not need to be painted. And that is it for all the 3D printed components in Tekkadan. Once more commercial off-the-shelf components arrive, more parts of the robot could be built, and we will be making more progress videos. This is Peter from Team Embarrassing Engineering. See you next time.